let's get started, shall we? So, before we do that, I want to play a game. Who wants to play a game? Yes, Paul. Here's your icon game. Has anyone played this game before? Yes, I expect full marks from this gentleman. Who can name all of the icons in the Azure portal? All of them. I cannot. Now, yes, they do change them weekly. So yes, we have that problem as well. Now, there are hundreds of them, and my icon game was getting to like 50 slides, so we won't do the full version. I have put a where clause on my icon game, where applicable to this session. So, easy one. Shout it out. Azure, good start. Ooh. Are we in the right room? Yes, good. Data Factory. Pizza boxes. Good. Another tricky one. Good. Data warehouse. Good. Not Synapse, is it? We'll see. Yeah, what's the icon for Synapse going to be? Who knows? What about this one? Yes, the water gives it away, right? These are all intuitive ones. Not so intuitive. VM, okay. You guys are good. Not intuitive. This is not a TIE fighter. A VNet, okay, good. Who's rich? Nobody's rich, apparently. Do we know this one? Express route. Anyone have this? Yeah, a few rich people at the front. What about this one? Storage account, good. Something to do with security? Key vault? You're very enthusiastic, sir. And because we're playing the short icon game, the one that underpins all Azure services, caffeine, yes, good. Thank you for playing the icon game. You win nothing. Did you know you can play the icon game at home with friends and family? They love this. Do go and get the stencil pack for Visio. The top link there is for the Microsoft SVGs, and then the one below is to my GitHub repo, because they change these things quite a lot, so I just put my own version of it in GitHub. So yes, you too can go away and play the icon game at home. Now, the great thing about a custom stencil pack in Visio is that the search box does not work. So you do have to scroll through these things. You do have to learn them all. Okay, as you can tell, this is where I spend most of my life. Good. We are now all warmed up, ready for the actual content, aren't we? So, Azure Data Factory, who's using it? Good. Who used version 1? My sympathies. We will all go for a drink together later. Okay. ETL in Azure made easy with Data Factory data flows. And as you've hopefully gathered, my name is Paul Andrew. I'm a consultant and architect from the UK, which is why I sound funny, but I talk properly. Not really. So let's do a little bit of title maintenance, shall we, first? Data flows. This is ambiguous. We have lots of things called data flows now, right? So to disambiguate it, let's just say, okay, we have data flows in Power BI, and now within Data Factory, we have a couple of different types of data flows as well. And as we will see, we can now separate them between a mapping data flow and a wrangling data flow. We will look at both in this session. If you're a fan of taking pictures, this is the one to take a picture of. So the PDF of the slides that I'm about to show you are already in my GitHub repo. Mr. Paul Andrew, the same as my Twitter and my blog and everything. So feel free to go and grab that PDF if you like. I'll be in the picture if you want. Done with pictures? Good stuff. Okay, so before diving into the actual content, I just want to cover off a very, very quick sort of little concept, and that is scaling up versus scaling out. Because we typically live in this cloud environment, and we say that, yes, the cloud is, highly scalable, but what does that actually mean for us? What do we need to understand about it? And this is particularly relevant to what I'm about to talk about after it. So let's just think about some workload, something that we have to do in the cloud. Don't really care what. And we need some compute to transform to do something to work with that data. And if we need more compute, we could add more CPUs, we could scale up some virtual machine or whatever, which is fine. We're scaling that up by adding more power to that compute node. Now, if we want to scale out, we're adding more compute. We're possibly distributing that work across more nodes, and that is where we're scaling out, distributing across multiple nodes potentially. And then at some point, whoever's paying the bill, we might need to make some sort of judgment between, do we need to scale out lots, or do we just need to scale up, or do we need some sort of thing in the middle? Okay? So that is scaling up versus scaling out, just as a quick baseline for everybody. So next then, let's move on to Data Factory. And as we probably gathered, there's a lot of people in the room that are using it. For those that haven't, I just want to give you a quick intro to Data Factory. And let's start with the question of, well, what is Data Factory? And let's have a timeline, shall we? And in 2016, when this service was in private preview, it was a sad Data Factory. It was unhappy. It was version 1. And it was marketed as SSIS in the cloud. And sadly, it wasn't. The marketing message was not quite there yet. But now, sort of 2019 and onwards, we have a happy Data Factory. Data Factory is now kind of more and more living up to that original marketing message, and even more so. So forget the history lesson and coming down to what is it in terms of what we need to understand. Well, if we have some process, we need to get our data from A to B to C to whatever, we can say that Data Factory is that umbrella service that orchestrates all of those things. It sits there above the process. It's quite bossy in that sense. And it will go and say to these other services, go and do this for me, go and do this for me, let me know when you're finished. To extend that, we could say that in this picture, my wife is Data Factory, and I am the one doing all the work. She tells me to go and do the work, I go and do it, I let her know when it's done. So yeah, it's the orchestrator of that. So let's go a little deeper into Data Factory. Again, for those that haven't used it, for those that are already using this will probably be familiar, but the components within our Data Factory, the things we need to build to allow Data Factory to orchestrate our process. First up, we have this idea of a link service, and we could say that a link service is like our SSIS connection manager. Are we fans of SSIS in here? Yeah, good. We're among friends, we can admit this. And we can use a link service within Data Factory to authenticate against something. The link service may give us the host name, the credentials, whatever, the bits of information to authenticate. And when I created this slide deck, I did a quick screen grab from the Data Factory portal, and I think we had 88 link services that we could connect to at the time. I think this list has probably grown or maybe even doubled by now. So Data Factory really can connect to anything. So those are our link services, number 1. Next up is this thing that we could describe as a data set. And this is where the data is. It's the metadata representation. Not the data itself, just the information we need to know about the data we want to work with. And we could say, in the case of a SQL DB, it's the schema, the table name, the structure of that table, the data types, all of those things. And that gets put into the data set. And the data set will authenticate using number 1, our link services. Next up is this thing called an activity. So when Data Factory is being bossy and telling other services what to do, it will use an activity tailored to the service it's going to talk to. And if we're calling a Databricks notebook, that activity will have information about the notebook it's calling, the workspace, the parameters we're passing, all of those things that we need. And like our data sets, our activities will authenticate again with our link services, number one. Okay. Next up is this idea of a pipeline. Now, we could say that within this flow at the top, we have a data pipeline, and sure, in that context, fine. But also be aware that a pipeline is a component of Data Factory, and a pipeline allows us to wrap our activities, to wrap up our things into these logical groupings. And more SSIS comparisons, if we said, yes, a pipeline maybe is a bit like an SSIS sequence container, sure, but maybe a better comparison would actually be to say that a pipeline is like our action in SSIS to execute another package. And we can call a pipeline with another pipeline. We can nest these things. We can have a generation of pipelines. And for completeness, of course, we can have multiple activities within a single pipeline. Okay? So that is number 4 done. Number 5 is this idea of a trigger. We want this thing to run. We want to execute it. And a trigger will attach to a pipeline, or many pipelines, and it will come in multiple forms. We can do this manually via the UI if we want. We can have a bit of PowerShell to invoke it. We could automate that and wrap it up in some other way if you like, but it's there under the manual option in my slide. We can have this idea of a tumbling window, which was renamed from version 1 as time slicers. And if we're working with time series data, it will allow us to define a timeline and then slice that timeline up by a given interval and frequency. And it's really good for working with time series data, but it's not a recursive thing. It's not like what we might expect with our SQL agent. It's there as an option. It was the only option in version 1. We have more capabilities now in version 2. Next, the thing we are probably used to, something that is like our SQL agent, that scheduled recursive thing that will just execute at whatever time we want. Next is a trigger that we can use for detecting when files are created in our blob storage. It's using the Azure Event Grid service underneath, and when certain paths are added or removed, we can actually use that to trigger our Data Factory pipelines if we want to do some event-driven loading or whatever. And then lastly, logic apps. So within logic apps, if we have some wider sort of bootstrap process, we can use logic apps to trigger our Data Factory pipelines as well. Okay? So that is it. That is your quick intro to Data Factory and the 5 components that we'll talk about for now that go into Data Factory to orchestrate something. And what I'd like to do is, a bit like SSIS, I'm just going to call out those components and we'll say that they are our control flow components. This is not a formal name, this is just my name for them at the moment. So those are our control flow components in our Data Factory. Next up is this thing called an integration runtime. And the name has been overused here, and we have 3 integration runtimes within our Data Factory that we need to understand if we're going to work with it. The first one, an Azure integration runtime. So we get this out of the box in our Data Factory. We can't avoid it. We have to have one of these. This is the little bit of compute behind the scenes that just allows our Data Factory to execute and invoke those services. It will auto-resolve itself to a given region. We can actually set the region. If we're doing copy activities, we can say, actually, I'll have my orchestration service in one region, but go and put the IR in another region if I don't want the copying of that data to move out of that region. It's there as the thing that we have to have for a lot of our activities by default. Next is our SSIS integration runtime, the thing that allows us to run our sys packages. We'll talk a bit more about this later, but it sits there as a cluster. We're abstracted away from it, and that will sit behind the scenes to run our packages if we need them. And then lastly is a self-hosted integration runtime. So we can use this if we want to reach down to our on-premises resources. It will act a bit like a VPN client almost. It's that gateway that will allow us to get to our file servers, our local SQL servers. We can even use ODBC drivers with this if we want. So 3 integration runtimes. And that covers off the what is Data Factory and what's going to go into it. If we then change the question and say, well, why? Why do we need Data Factory? And for me, the answer to that is if we step back a bit and we have something like this, and this picture is deliberately busy and deliberately complicated. If we have some modern data warehouse, some modern analytics platform that may or may not look something like this, this is just a very generic representation here of what we could do if we're using Azure PaaS tech. And why Data Factory? Well, in this picture, Data Factory for me is an essential component to orchestrate all of that stuff. We have to have it in there, to schedule, to monitor, to manage. We need that Data Factory component. So, quick recap, the why and the what, 5 components, 3 integration runtimes, quick intro done. Next, transforming our data. The hard part, right? The stuff that's difficult. Well, what we now have is that from our control flow, if we want to transform our data, let's just think about our options for doing that. How do we do that in Azure? How do we transform the data? Well, the obvious one, of course, is using Databricks. This is good. Do we like Databricks? Nobody likes Databricks? One chap over there likes it. Good. Well, the argument I'm going to put to you is that yes, Databricks is a good tool. It's a mature tool. It's been around since 2013, but it's not necessarily a natural fit for all of us. It wasn't for me. And the reason for that is because if I want to use Databricks, potentially I might need to go and learn about Spark. I might need to learn Python. I might need to learn Scala. So maybe there's a steep learning curve here if we want to do that and if we need to write that code. Just for now, this is my argument. If we want to transform our data with maybe our more sort of SQL-orientated relational stores, I'm going to make the argument that if we're using our SQL DB, that is only going to scale up. We can only add more compute to it. It's going to sit there. It's not going to distribute that compute for us. And if we're using our SQL data warehouse, I'm going to make the argument of it's quite an expensive tool, maybe, and also, if we're dealing with less than a terabyte of data, as a rule of thumb, we probably don't want to use that service either. So again, no sort of perfect fit here. Going a bit further, we could use HD Insight, sure, but we've got sort of issues now with manually configuring those clusters. We could do that, but it's a little bit more effort. These are not deal breakers, I'm just saying that it's not perfect. It was also quite expensive until Databricks came along, and then Microsoft slashed the price of it as well. And then going further, we could use Data Lake Analytics. Did anyone use this? Just one gentleman over there. Did anyone invest like a good 2 years of their career working with this service and learning USQL and blogging about USQL and Microsoft canned it? Just me then. Thank you for your sympathy. Okay. And of course, yes, future uncertain for Data Lake Analytics. We then maybe in Azure Data Factory could create a custom activity. Has anyone done this? Okay, just me. So if we want to create a custom activity, we could write our own, C#, whatever. We can compile this down to an executable. We can wrap it in Data Factory. We can do that. But that's a lot of effort. We've got to hand crank everything in that situation, and we're going to need some infrastructure to run it on as well. So not perfect. And then lastly, our good old friend, our SSIS packages. And as I've said, we have that SSIS integration runtime sitting underneath our Data Factory, and we have this cluster of compute to run those sys packages. But that's quite expensive, so we might need to stop and start it. It doesn't always come up straight away. You're talking like sort of between 5 and 20 minutes for that to come up. So a little bit of effort, a little bit of management. And because we like SSIS, I like SSIS, let's just explore that option a little bit further, because I think there's probably a lot of people in the room that have invested heavily in sys packages over the years. You know, this was a mature technology, and we might want to explore lifting and shifting our sys packages to the cloud. Yeah? If we want to do that, we will need a SQL DB to house our SSIS DB. We need this, and when we deploy our SSIS integration runtime, we get that. We will need a logical or a managed instance for that thing to sit on. Fine. We then, maybe we go away, we do the work, we have Visual Studio or whatever, we create our sys package, that's fine. Now, the SSIS integration runtime can actually have 10 nodes within it, and we can actually run 8 packages per node. So we could potentially scale out here, but we're not really scaling out in the way that we want. We are scaling out in the sense that we can run 80 packages at once, sure, but we're not scaling out because in this scenario, only one package is only going to get an 80th of that compute. So the actual data flow that I've got in the slide, we're not going to have that distribution of compute in the way that we want. This is just scaling out at a high level. And also just be mindful that if you have a scenario where you have a parent package that's calling child packages here that is still only going to get an 80th of the compute, you need to refactor your packages to make Data Factory the parent in that scenario. So, considerations. There is one fairly good design pattern for this, and that is that if you are rich and you have ExpressRoute, you could use the infrastructure there to connect to your on-premises resources, and maybe that cluster of 10 machines is going to be better than the hosted integration runtime. So it's kind of an it depends situation. And so, Paul, well, I'm not going to have all these packages. I'm not going to have 10 machines. I'm just going to have one big fat machine. And it's like, yeah, fine, okay, we can do that. But then all you're really doing at that point is paying for a SQL Server VM that you can't actually access, that you're abstracted away from. And we are then, again, only scaling up that single node. We're not having that distributed compute in the way that we want it. So these are my arguments. They are, they're imperfect arguments, I accept, but this is where we're at for now. And these are our options if we want to transform our data in Azure as I see them. So what else can we do then? Well, of course, the saving grace here and what we're leading to, and hopefully what I've led you to, is using data flows, this new component. So what is it? Well, in the context of our control flow that we've looked at, we can now actually say, well, within our pipelines, we have this new activity, these new activities that are our wrangling data flows and are our mapping data flows. And they sit there in our number 3 component. So let's firstly take a look at our mapping data flow. Why is this good? Why is this exciting? Well, in Azure, in the Data Factory portal, which we need to use to develop our Data Factory, we can build a data flow that looks something like this. Now, this looks very much like SSIS to me. Do we agree? We've got this rich UI where we can bring these things in, we can do this work. And the exciting thing is that behind the scenes, we might have some JSON that's kind of housing that data flow and the things that go into it. But the really cool thing is that actually, with a bit of Microsoft secret sauce, that data flow will get converted into Scala, it will get compiled, and then that jar file will be passed to Databricks to execute on that Spark cluster. So if there is a barrier to entry before, we've now overcome that because we've been abstracted away from it. We've got this very friendly UI, and we can now work with these data flows in this way. And we know that underneath we are actually using Databricks, and we are potentially going to have that cluster and that distributed compute that we want. Is this exciting? Is this good? Yes. Yes, Paul. Okay. So let's look at our mapping data flows then. We had those 5 components of our control flow. What do we have within our data flow that we need to understand? Well, firstly, the new activity that we'll take a look at in a moment. And what we'll see is in the settings of our data flow, we will have this thing called a staging area. And if we are loading a SQL DW, for example, we can use the staging area, which will reference some blob storage where those files will be staged and then loaded into our DW via Polybase. So, just bear in mind what these settings relate to when it comes to the underneath workings. We then also have this option that says run on, and this is where we define our Databricks cluster. But you remember when I said that we have these 3 integration runtimes within our Data Factory? It's that first one, our Azure integration runtime, that references our Databricks cluster. And what you'll do is when you go and configure that, you can say for that Azure integration runtime, I want a cluster of a particular type, a particular size. This is where you define it. So just bear that in mind within the settings of the activity. That's what it is running on. Next, then, if we go into the data flow and we look at the source and the sink or the destination, when I created these slides, we had a few different options available. The top 3, we could probably argue they're all the same thing at this point, but I think the limitation here is that whereas in the control flow we had 80, 100 or so linked services that we could talk to, within our data flow, because we're probably using Scala underneath, we're limited by what Scala can connect to. So considerations there, whether we need to bring our data into some other storage, then work with it within that data flow, or do we connect directly? So this is what's currently available when I took the slide. It could be out of date. Next, then, in our source, we can do some cool things about saying, well, is the schema going to change? Do we want to validate that schema? We can handle this. We don't need to write any code. We can just tick some boxes and it's taken care of. It's all good. Just maybe understand the implications of what's happening, but it's nice that we have those options there. We do also, at the bottom of my box there, have this thing called sampling. I was very excited when I first saw this. I thought, yes, sampling over our big data, brilliant. But really, this is just doing select top 10, top 1,000, whatever. It's not actual data sampling. Yes, sir? Are
you going to go into a little bit more detail on allow schema drift?
Am I going to go into a little bit more detail on allowing schema drift? No. But we can talk about it later if you like. Next up, on the sync side, and in a few other places as well, we will see in the settings this tab that says optimize, spelt wrong, but that's what it says. And we can actually say, I want to control how my data is distributed. We can say that actually I want to round robin that data, and again, via the UI, we get to control this. This is easy, this is nice. I don't have to do a lot of work for this. I can just set these things in the portal, great. In terms of the transformations themselves, this is the hit list. When I created these slides, and if we're doing a bit of SSIS translation here, I could say yes, we have a multicast, we have a merge join, without the sorting, but yeah, we have that option. My favorite is the surrogate key one. So if we want, that row number, that auto-incrementing ID on our data set that we're bringing in, we can get that. We can just have that surrogate key in there. Good. We have a script component equivalent where we can write our own Scala and we can compile it and we can give it to our data flow to work with alongside our process. But I'd make the argument, well, if we're writing Scala, compiling it, giving it to our data flows, why don't we just write all of our transforms in Scala? Why do we need data flows to wrap that up? But the option's there if we want it.
How does surrogate key affect performance?
How does the surrogate key affect performance? It depends. I don't have a good, if we're talking, volumes of data, and maybe you could tell me. Yeah, it really depends. Moving on with our data flow, we can also have an expression builder, or we get an expression builder, a very rich expression builder. Things that we're used to in SSIS, we get the same capabilities here. And my favorite is the regex one. We can do regular expression, pattern matching and things in our data flows as we go through. In SSIS, we might have used a script component to do that and put some C# in. Here, we get that out of the box. Great. We also have something that I've deliberately left in this screenshot of this debug mode. We can turn this on, and if we turn this on, we can actually look at our data as we're going through. We can say that, yes, enable it, and then we will get a preview panel. So for every stage of our data flow that we build up, we can actually see what's happening and what's going on. So no more in SSIS where we might create a data viewer and multicast things just to kind of like look at that data as we go through. Now with this debug mode enabled, we can preview it as we build this thing up. Nice. Just be mindful though that when we do this, when we enable this, it's using a general purpose cluster underneath. So it might not necessarily perform as you expect when you deploy it, when you configure your own integration runtimes. Lastly, we have monitoring. Yay. But monitoring now, which because we're going to Databricks to do the transformation work, what we're bringing back is those Spark logs, and what we'll get is a parsed set of those Spark logs, and we'll get some fairly rich information about that monitoring, about the row counts, the partitions, and all of the things that we've probably just come to expect. We get that capability as well. Great. So, quick recap, if we said that we had 5 components of our control flow, what I'll say to you is that here are maybe the initial high-level 6 bits of our data flow. And what I've done for you in the slides, I've just added all the Microsoft document links, plus one more for this chap. Hi, Mark. So this chap, Mark Cromer, I've also included a link to his GitHub repo because there is a lot of resources there, a lot of videos and things. You can see them via the portal as well, but useful link there as well if you want to go and have a look at those resources. He blogs and writes far more about this stuff than I can actually keep up with, so check that out as well. So that was our mapping data flows. Now let's turn our attention to our wrangling data flows. And I think you probably caught the announcement in the keynote that now wrangling data flows are in public preview, so we can all go and play with these. And, we have a very similar story. We have a screenshot, and we have an environment that looks a little bit like this. And we have maybe some JSON or whatever, and like with our mapping data flows, that's being passed off to a Databricks cluster, and it's going to go and do the work for us. Great. Now, what does this look like? Have we seen this? Does this UI look familiar? Yeah, of course it does. It looks a little bit like our Power BI Power Query, right? Because pretty much it is. Great. We now have the same sort of Power Query capabilities, but within our data factory. And we can right-click on this thing, and we can go to Advanced, and we can actually see the M that is going into it. And we can use that, if we're comfortable doing that. If we read enough of Chris Webb's blogs, we can say, yes, actually, I'll use this M in my data factory to do my transformation work because that's the thing that I'm comfortable using. Sure. And of course, we go off, we do that works, we're happy. So another option there are wrangling data flows. Slightly different UI, a veneer over the thing underneath that's still doing the work. So let's take a look at it, shall we? Note to self, start the clusters, and pray they don't take too long to come up. Let's start this one. And let's have a refresh on this one. Yes, sir.
So, if I already have a lot of analysts built, lots of Power Queries and Power BI, am I able just to copy and paste that into the advanced editor or wrangling flow?
I'm going to go with it depends. Sorry, the question for the rest of the room was this gentleman who's got a lot of Power Queries in his Power BI workbooks and things, can I just copy and paste them into my data flow? I expect the answer at some point will be yes. At the moment, while the service is in public preview, some of the transform capabilities are limited. They don't work yet. So probably some of that M code will work, some of it might not. I'd say it depends what it's doing. But expect at some point that is the vision, that yes, you'll be able to do that. Okay, cluster started, good. So given what I've shown you already, the case and the argument that I want to make is, let's do some data transformation. Let's do it in 4 different ways. And we have a good old AdventureWorks database here. And I'm going to focus on the order header detail table and the order headers itself. And first query, first bit of transformation, for the DBAs in the room, this is called an aggregation. I'm just joking. So we query our data, we get things back, we aggregate, we count the lines. You know, we can see what this is doing. Nothing complicated. But I'm transforming that data using T-SQL, and I'm running it in a SQL DB, which is fine. Yeah, this is 32 rows, it's quick, it's demo friendly. But as I said, that SQL DB, you know, that is only going to scale up. We will have a 4 terabyte limit on, you know, the default service if we're working with that. So some considerations, but we can only add more compute to that SQL DB. We can only scale it up. So I've then got the 4 tables, which is just the output of that. And then, whoops, didn't truncate them all. That's cheating. Let's run that one again. So 4 output tables, first one with T-SQL, done. Then let's break out our friend SSIS. We like this. We have a local developer experience, which we do not for Data Factory, despite me keep asking. But anyway, I'm not bitter. And of course, we can do the same thing within our SSIS package, joining the order headers to the order details, aggregate, output, run, nice and easy. Great. Great, come on. Again, demo friendly, not huge amounts of data here. But the same argument, that is potentially going to sit on a node within our Data Factory on that SSIS IR. We can only scale up the execution of that package. So stop debugging, yes, good. We have 2 tables populated. We've transformed our data in 2 different ways. Great. Then let's turn our attention to Databricks. Let's do the same thing. My cluster hasn't started, of course, because I'm demoing it. It always takes longer. So what I've got within my Databricks workspace, I have a notebook that's not attached to a cluster yet because it's not started. And with my Pigeon Scala that I mostly Googled, because that's how we develop these days, I am able to connect to my SQL DB, and I'm a bad developer because I've hard-coded my connection information in the notebook. Don't do that. Apparently it's something to do with security. So I can create some data frames. I can write the same SQL within my notebook. Do we like notebooks? Yeah, woo. And, you know, very much like my previewing capabilities that I had before, I can actually execute that SQL. I can get the same results. No surprises here. And then I can just write that content back to my SQL DB as well. Let's just run that one. Obviously, all of these things are fairly quick, but with Databricks now, because we have this cluster underneath, you know, we have that expectation that this is now going to scale out if we need it to. It will auto-scale, it will look after that. But because of that capability, we have this higher barrier to entry, but then potentially that linear scale once it's running. Running command 1. Now, my cluster has started, sir. Yes, thank you. It was a tense moment, but it was okay. Running command number 5, and then lastly, doing the write back to my SQL DB. Again, nothing complicated here, simple transforms, just doing it in the 3rd way. Running, running, running. I paid for the cheapest cluster possible, of course. Good, finished, confirm, yes, third data populated using Scala, fine. So that's okay, but you've got to write Scala or Python or whatever to do that work. So of course, let's turn our attention to our main feature. Let's do the same transformation work now with a mapping data flow. So within my fun factory, as I now call it, top tip, if your family ever ask you what you do for a job, don't tell them you work in IT, because then you'll then end up fixing their printers and things for the rest of your life. Tell them you work in a factory. Yes. That's what I do. I do not get technical support calls from my family anymore because I work in a factory. Good. Excellent. Mischief managed. So let's add a pipeline. And then we can go in here. I'm going to bring on my new activity, my data flows. I'm going to create a new data flow. And I'm now going to have my mapping data flow. And we get this experience. Let's just zoom in slightly. So what I've done is, because I'm cheating, this is a demo, I've configured the link services, I've added the data sets to my SQL DB table already, and again, slightly cheating. The reason for that is simply because I can very quickly infer the schema from my SQL DB table, not that one. It has that metadata, it has that information, it understands what's in there, and I can just say, go and inspect the table, bring back the data types. Of course, if we were working with CSV files or something, this might be a little harder, but I've used the SQL DB table for ease. So I'm going to add my source, and we have, of course, my order headers, and I'll say, yes, use my pre-created order header data set. Great. Next, order details. I can't type when people are watching, so if you could close your eyes while I'm doing that, that'd be great. Fine. Next up, my transforms. Here's the list. I'm just having a quick scan to see if there's any new ones. No, there isn't. Join it. Inner join. Yes, please. Join on my sales order ID, the primary key from that table, oops, and let's select the order details. And yes, the sales order ID on the right-hand side. Not complicated, we know what's going to happen here. But we could, of course, preview the data. My debug cluster has thankfully started, so it can do that sort of lazy read. It can fetch that data, and it will bring back that for me. Won't you? Everyone concentrate really hard on that circle that's spinning around. It makes it go faster.
Now in real time, it's generating all the Scala and sending this over, or the jar files and sending it over to Databricks?
Yes, sir, yeah. It's doing all of that good stuff to bring this back for me. Question, sir?
Yeah, SSIS always had the problem where it read only the first 8 rows unless you
Yeah.
ETL.
Yeah.
Does Data Factory do a better job of that?
SSIS always had the problem of only reading the first 8 rows and then probably getting the 9th row wrong because maybe the data type was different. Does this have the same problem? In the cases that I've found, not so far, but yes, my expectation is that it's going to, look at, yeah, I forget the Databricks display capability that it does, but yes, we're okay so far in previewing this.
Is there like a percentage sampling threshold or something?
Yeah, I imagine there would be a percentage sampling threshold underneath that's determining that. I don't know exactly what that is, but yeah, we're abstracted from that. So I've done my join. Next up, let's have my aggregation. And in here, yes, we can say I want to aggregate on my sales order number, grouping by that, and I can break out the expression builder, and we've got all these great things in here. Of course, I just want a very simple count, and I want to use my input schema, and I want my sales order detail ID. Finish, And I'm just going to call that record count. And then lastly, the sink, the destination. And the sink is going to be to my pre-configured data set. And what I'm going to do is in the mappings, I'm not going to auto map it. I'm actually going to say, yes, okay, the sales order number was correct, but actually I called that record count there. It actually goes to detail line count in the table. Fine. Save that. And then back to my control flow level, we can run this in debug mode. And this will take about 2 minutes to execute. So by comparison, we had our T-SQL, which of course executed very quickly. But then we have that scale-up problem. We had my sys package. I ran it locally, of course, but yes, it executed very quickly. We had my Databricks notebook with the Scala doing the same work. It took a little bit longer. We had to start the cluster and things, but fairly quick. Now, with my mapping data flow, this is running, but if we think about obviously all the plumbing that's happening underneath, this taking about 2 minutes, it's like, yeah, okay. Because it's got to do that work, it's got to compile that code, it's got to pass it to Databricks, it's got to bring back the logs, parse the logs, and then give us that monitoring information. So if I just keep repeatedly hitting refresh, which is another top tip for making everything go faster. Sorry, this is just an English sense of humor. Click faster. Yeah, not demo friendly, but there is a point to this. We are going to make it faster in a moment. Can you view the monitoring while it's running? No, we do need to wait for it to come back. Mark? Click the eyeglass, okay. Oh, we can view the monitoring while it's running. Sorry, we can now do that, yes. Question, sir, at the back. Can I use T-SQL in Data Factory? No, but maybe that's what we can do with Synapse. Ooh.
Yeah, my question as well. Can you have in your data set, can you have the actual T-SQL embedded?
In your data set, can you have the actual T-SQL embedded?
All that's happening within the data set.
Not the T-SQL here. We are building this up in the graphical interface. This is what this is doing. Not the T-SQL at this point.
You can't define in a data set instead of connecting to a table. You can say, okay, I'm defining a query. That way you can typeset the query.
Yeah, like we could very much like an SSIS define the source as a query. But yeah, at this point, it's just very much a lazy data set that I've created.
But at this point, it's not using any T-SQL. It's just using a generic SQL because it's executing this all.
Yeah. At this point, it's not using any T-SQL. It's doing the work for me behind the scenes to write whatever code it needs to achieve this. So my data flow is finished. It took 2 minutes, 5 seconds. Eyeglasses, here's our monitoring information. And, we have our default 200-odd partitions that's been created for this, which is very overkill. We don't need that, but we can see them. And if we look at my sync, we can see that this is actually taking a staggering sort of 2 minutes to do that sort of stage. Sorry, 1 minute to do that stage, 1 minute, 15 seconds. That's a lot of effort. I don't want that. I want to make it faster. So what we could do is we could go to our data flow and we could say, actually, within here, I just want to tinker around a little bit. And maybe for my joins, I can go to optimize, spelt wrong, and we can say in my optimize panel, broadcast the join. So ticking a couple of boxes, we can actually say that if possible, keep that data in memory and do that work and do that in memory as part of this join. Let's do that. Let's see if we can use that to make it faster. Let's also look at my sync and let's optimize that as well. And instead of using those default 200 partitions, I'm going to say I want to set the partitioning. I'm going to round robin it, but I only want 10 partitions. So we can save that. Good stuff. And I can go back to my pipeline, and I can hit debug, and let's see how that's affected it. I can tell you how it's affected it. It's basically halved the time it takes. Any other thoughts while this one's running? No?
How long did it take for the SSIS package to run?
How long did it take for the SSIS package to run? Well, no time at all, seconds. Let's run it again while we're waiting. Let's run it 3 times while we're waiting. I mean, this is running locally on my machine, of course. It's bringing that data down, and it's pushing it back up to that SQL DB. But yeah, no time at all. This is a very small amount of data. So, this is not really representative of what you want to potentially use this tool for, but it's there. 42 seconds, 50 seconds. Yes, sir. Another question?
Did you get any benefit because this is the second time you're running or anything like that?
No benefit at the moment. No, it's got to do the same work, but obviously now with some tweaks that I've made. Ooh, 50 seconds, 49 seconds. Great, even faster. So if we look at the glasses again, as the things that we expect in the sync now, we've reduced that from a minute, 15 seconds to now 11 seconds. This is good. A few ticks via the UI, we've improved the performance there. Yes, sir. Does it take advantage of the SQL execution plans? No, sir, because it's not using SQL here. This is working with Databricks abstracted away from. So we have created that data flow. We've done it nice and easy. While we're in Data Factory, because we did that transformation using those 4 different methods, I did also create a wrangling data flow of the same thing. So just to have a little look at it. This takes about 6 minutes to run when I did this, so I'm not going to run this one, but we can have a look at, of course, the user interface. I have my order headers file. This was actually a text file in my data lake store. I didn't use the SQL DB for this one. And the header details as well, of course, and then I created the user query to do that same aggregation. And I can look at the advanced editor. We can see the M, very simplistic, of course, but we can see that work. And we have, this group by, we have this environment there to do that. And we wrap up our wrangling data flow very much in the same way, and we execute it as an activity within our pipeline, and we get those same capabilities. So there's a 5th version of doing that transformation if you prefer that way of doing it. Okay. Let's jump back to the slides then. Where's my clicker? So the point of that demo was very much this, that with our T-SQL, I've labored this point, we need to consider where we're scaling. And we say here that with that SQL DB, we are scaling up. And with our SSIS, we're scaling up. But the point as well is, what's easy? Do we get that graphical interface to actually build our transforms? Yes, with SSIS, absolutely we do. With Databricks, we get the scale-out capabilities we want using that cloud-native tech, but we don't get a UI. We get a notebook, which is fairly nice, but we don't get a SSIS-style UI. So, some design patterns then. Now, these are, of course, not perfected. This is just food for thought. How do we want to now use our mapping data flows? Well, if we have some process that we're extracting from our source systems, landing it in a data lake or whatever, we could, yes, say that maybe let's use our mapping data flows to build 80% of the hard work, and then maybe we have to do 20% of the other stuff with Databricks if we don't necessarily have those transforms there yet. Sure, I don't mind, this is food for thought. And of course, the goal is curation of your data, and then maybe we are loading it into some data warehouse at the end. Sure, we could do that in this scenario, or maybe let's swap those 2 round. Let's actually say, I'm going to do some of the heavy lifting first with Databricks, But then, because of that staging capability that we get within our mapping data flow and how easy it is just to enable that to load our SQL DW, maybe we actually just use the mapping data flows to do that part of the work. Again, I don't mind. This is a very much it depends scenario. It's whatever we're comfortable with. Or, if we want to keep things in memory, I'm not going to discount the fact that, yes, we could just keep everything in Databricks. We keep everything in memory. We pick it up once, and then, we persist it. So, sure. Also, bear in mind that with our mapping data flows, and the JSON that goes into it, at our control flow level, we can very dynamically inject into those activities, those data sets, those linked services. At the moment, with our data flows, we don't have all of that capability. We can add some parameters. We can use those parameters within our expressions. But actually, if we look at the JSON that goes into that data flow, we'll just see this sort of line of script in there. We don't necessarily have the capability to use BIML like we did with our SSIS packages. We can't metadata drive the creation of these data flows yet. I have heard rumors that the people that did create BIML, I believe, are maybe doing something similar for mapping data flows to kind of give us that capability if we want to crunch out a load of these, given some common pattern in our data. But those are just rumors. I don't know if they're true or not. Tweet Mr. Scott Curry and see what he says. What else? Well, for me, and based on what I've experienced so far with our mapping data flows and our wrangling ones, the question could be, well, when do we use one, when do we use the other? I don't have a good answer, but my conclusions at the moment would be that maybe we do some exploring, some experimenting with our wrangling ones. Maybe we allow our Power users that are familiar with Power BI and Power Query to go and do some of this. Sure. Maybe we use our mapping ones for productionizing, for doing the sort of the engineering, the loading of the warehouse. Again, I don't mind. This is just food for thought, given this new tech, this new offering that we've got. So, wrapping up with a few more conclusions, in our modern data warehouse, in our analytics platform, or whatever we want to call it, where we had Databricks in here doing that transformation work, we could actually say now that we can maybe replace some of that Databricks work with this UI. We could use that capability. Another argument that I've made, I was at an AI conference a couple of months ago, and I was surrounded by data scientists. I felt very uncomfortable. And I said to those data scientists, well, if we have a very much extract, transform, load type scenario, and we have our beardy data scientist that has to then go and do data science, whatever that involves, he or she, of course, has to maybe go and get that data. They have to bring it down. They have to maybe load their models, train them, and then they have to give insight back and inject that into some serving layer or whatever. I assume this is what these people do. And what I do know is, and the argument I made to them was, if you're a data scientist maybe doing this, 80% or so apparently is the sort of rule of thumb. They have to spend 80% of their time doing that data engineering. I said, that's a lot of effort. Don't do that. Use Data Factory, use these wrangling and mapping data flows in there to actually achieve that, because it's easy. It gives you that UI, it gives you that capability. You don't have to write code. It does scale. It's lovely. So coming full circle, I said to you originally, what is Data Factory? And what we can now do is we can extend the answer to that question. We can say that Data Factory is the orchestrator of our control flow capabilities. It is also potentially the orchestrator of our data flow capabilities now as well, drawing that same comparison that we had with SSIS, where we have the control flow, the data flow. For me, it's the same sort of thing. But, of course, for completeness, let's just extend that and say it does give us that capability now using that cloud-native tech. and with that very rich user interface, that graphical interface that we want to work with, which is nice. This is helpful. And with that, that is it from me, folks. Thank you very much for listening. As I've said, the slides, if you want them, are in my GitHub repo, so please feel free to go and grab a PDF of them. Thank you.